Very good afternoon now, and thank you for inviting me here. Catching up with the previous speakers, I selected my presentation to be about the climate change, refrigerants and building codes, and I'll be talking about other parts of the world. I'm a professor of energy at Cairo University, also ASHRAE fellow, and I'm a board member at the time. So we need standards, we need codes, and if you look at the time scale over the past few years, you will see that we start by the building envelope, moving along to the heating needs, energy use for heating and cooling in the buildings. Then we move to the overall building energy performance, and these days we move to energy producing built environment. Let's go to some definitions. I made these slides for people who are not 100% familiar with what we're talking about. So I dragged the definitions for climate change and put it over here. Global warming, these are some of the terminology that we heard or we are hearing a lot these days. Greenhouse effect. All this come out with the recent researches that tells us that we have abused our environment by using a lot of refrigerants that are or have damaging effects on the environment. I called this from an IEC standard that is in the very final form. It's an FDS. What are flammable refrigerants? And the reason I mentioned that because we have a lot of problems these days with refrigerants that are causing global warming, and now we are looking for other type of refrigerant they use for air conditioning and refrigeration, and the problem of flammable refrigerants surfaced up. One of the codes that I stress on is qualified person. When using refrigerants in other parts of the world outside Europe and the US, you need the people to be qualified how to handle refrigerants, not to purge into atmosphere. So we need really special foremen, technical people who knows exactly and have enough training on the use of refrigerants. Now, first we spent, after the Montreal Protocol, quite a span of time into the effect of the ozone depleting material, and now they realize some problem with the global warming potential, and here the definition of global warming potential, and you see that most of the refrigerants listed on this table have significant global warming potential, and that's why, and these are measured versus the carbon. And recently in 2016 in Kigali, there was an amendment to restrict the use of material that are causing global warming, which means, for example, how we calculate the global warming of a mix, and take, for example, the refrigerant 401A, which is heavily used, and that's how we can get the global warming potential. So these are some of the refrigerants known to us these days, and at the far right-hand column is the expected global warming potential of the blend. So it means we have a problem, and we have to look for new refrigerants that has no global warming potential, and also are not flammable, because if you think about, for example, when you're using VRF, where you have your condensing unit at one spot and you have your evaporating unit at another spot, and the distance is about 50 meters, then these pipes will have flammable refrigerants, and a lot of precautions has to be taken into account. So this is a list of where we stand. As I come from Egypt, at the present time I live in Egypt, so we have what we call Article 5 in developing countries, where by the year 2016 we should reduce the use, 2040 stop the use, and the arrow shows where we are at the moment. So these are some of the major stops. So these are the base level for the refrigerants and the implication for the developing countries. I hope countries will follow this, not 100% fully, but we have a lot of restriction for that. Now the main characteristics of refrigerants are the flammability, toxicity, evaporation, heat capacity, and thermal conductivity. From a mechanical engineering point of view, I'd love to have the best heat performance, so I get the least amount of refrigerant going through. These are some of the history. I have to cut my presentation short because of the time. So we have different categories. We have hydrocarbons, we have halocarbons, we have inorganic, and we have blends. And I think these days we use a lot of blends. I'm engaged now in what we call the Arab countries code for refrigerants. We are building a new code for the Arab countries I chair. So we have to tell people the blends, identify what are pure refrigerants and what are isotropic and so on. The ideal refrigerant properties, non-toxic, non-flammable, compatible with other material, easy to manufacture, easy to handle, and no or low environmental impact. Of course, a commodity that's very difficult to have. So we have to go to alternatives. And with alternatives, you have to look at the global warming index, the ozone depletion index, toxicity, performance, and flammability. I assure you that ASHRAE is heavily involved in this, and we have also ASHRAE standards for the refrigerants, as well as the ISO standards as well. So if you look at toxicity and for the higher pressure, so we find that the green CFCs are the most probable, favorable refrigerants. They are not flammable and they are not high pressure, because high pressure means high compression means more energy put into the machine. And also, if you look here, you will see that some of the material are on the toxic side, and the ones in greens are the ones like refrigerant 113, 123, 134. All these are in use now. And now we have the, with ASHRAE, we have the flammability limits, and lower toxicity is highly recommended. So we have the international coloring code for the different refrigerants. This is for your knowledge. Examples of the blends, like refrigerant 134A, which is used for cars, 40C for condensing units. We all calculate and design codes for buildings in order to be able to specify the basis of design and condition for execution. So the code, any code, is a set of documents that make it easy for you to give you the minimum basis of design. What are the guidance to design, and also conditions for execution, how you execute, how you construct. So I call this building code. It's a set of rules to specify the standards for constructed objects such as building and non-building parts. If we try to make a new building code, of course we have in the US we have more than one building code. In Europe we have the EPPD, and when we think about the other part of the world, the developing countries, we thought of the code scope, and by comparison we found that we have to include these parts: the building envelope or the facade, ventilation, air conditioning, lighting, electric power distribution, service water heating, building energy performance compliance, and so on. So we have basic codes, and we have also additional codes. We all like to specify the outdoor conditions and indoor conditions. Outdoor conditions we get from the references, and these are very well listed in the ASHRAE fundamentals, and also for the weather stations worldwide. Indoor are recommended in our textbooks. So for the energy design elements of any building, we like to concentrate on the window design, roof and wall, atrium design, use of daylight, interior design, low energy, and building orientation, and energy management. So we look at I'm not an architect, I'm a mechanical engineer, but my best part, my wife and my eldest daughter are professors of architects, so I have to learn a little bit. The way you build your building, the way you make your facade is very important to save energy. How you make carpets, how you make shading is very important. How you use daylight, not artificial lighting. And today we heard a lot about lighting and how it affects productivity and so on. So these are parts of the ISO code for energy. Why we have the building? We have the building envelope to protect us and to shield us from the outside. Like it gives us protection from the climate and from the organic agents and from inorganic agents as well, from seismic forces and from different site conditions. So we have to shield the occupant inside the building and provide good shelter for it. We have a problem of moist migration. This is why we have to make the walls moisture resistant. And we have to look for different sources of energy, like solar and passive energy types. Passive solar will be from the design concept point of view, and it can be simple, and it can make the building more beautiful, appealing to people. So the need to restrict the air movement between various departments in any building, specific requirements for each of the zones in the building to prevent any microorganism transfer from one place to another, and also to keep the building clean with specific air filters. And today also we heard about the MERV and the various categories of the filter. So we can do some zoning, provide flexibility for operation, and use mechanical cooling. Noise criteria is very important as one of the source of pollution, and all we have to do is to do the appropriate acoustic treatment to prevent any noise with reference to the ASHRAE guideline. Also for the vibration. Recently, and I mean recently, the past 30 or 40 years, we started using control system. Building management system used to be optional. Now it is mandatory to use it for energy efficiency and also for better performance of the building. When we start designing and building a code, we have to look worldwide what we have, what chapters this code includes, and we summarize them into 9 categories or 9 chapters. And here is a list of the various codes worldwide, and you find that all of them have most of the 9 chapters. So in the US, for example, we have the MEC, and we have the different applications. In the world, its assumptions do not work for the Arab countries. And the IEC also, we have checked the MEC, because each of these codes, we have 3 categories. Compliance requirement, either prescriptive, you specify a value. A building will have so many kilowatts per square meter, that's it. Or you can have trade-off. You can have more energy used for air conditioning, but you use less for your lighting system and so on. So at the end, you make a balance and you don't exceed a certain value, or you plan and do a building calculation or performance. So here you have the ASHRAE 90.2, which is out and applied. We have the California Title 24. I'd like to stop with this summary, but I always show this because my friends ask me about my cat. So this lovely cat used to sit down by my desk for the past 20 years. He's old, he's 20 years old now. And this is his asylum. He's a friend of my daughter when we were young. So he comes and hides on my desk. I mean, they cannot touch him while he's there. And if you have any question, I'll be ready to answer. By the way, a lot of people ask me if he has one hand, one arm. But no, he has 2 hands. Thank you very much.